which has 3 capacitors, 3 resistors in the arrangement shown. The capacitors in the figure are fully charged and the switch closes at t equals 0. So at t equals 0 we get a switch like that. As soon as the switch closes, charge begins to flow, so current starts to go around the circuit. The question is, at what time has the current in the 8 ohm resistor, so the current through this part right here, what time has it gone down to half the value it had initially? So the initial current would be I0. We're asking at what point is I equals 1/2 times I0. So we know this is an RC circuit. The first thing we can do is we can simplify to find the equivalent circuit. So let's do a sketch and let's have a look at how we analyze all the different parts. This will be a bit of a step-by-step process, but maybe we can combine a couple of steps in one. Okay, first step we'll do is the two 60 microfarad capacitors. These two guys are in series. So if we wanted to find the equivalent capacitance, 1 over C equivalent is 1 over C1 plus 1 over C2. 1 over 60 plus 1 over 60 equals 2 over 60. So our equivalent capacitance for those two guys is 60 microfarads divided by 2, or 30 microfarads. That's that one. Then we have a 30 ohm resistor and a 20 ohm resistor. These two guys are in parallel. We want to find the equivalent parallel resistance. So 1 over R equivalent is 1 over R1 plus 1 over R2 equals 1 over 30 plus 1 over 20. 1 over 30 can be written as 2 over 60. 1 over 20 is 3 over 60. So we get 5 over 60. So R equivalent then is 60 over 5, or 12 ohms. Okay, let's redraw that circuit and we'll see if we'll be able to finish it. So this one is now 30 microfarads. This one is 20 microfarads. There's our 8 ohm. This one is our 12 ohm. And then these two capacitors are in parallel. For parallel capacitors, we know that the equivalent capacitance is just those two guys added up. 30 microfarads plus 20 microfarads equals 50 microfarads. And then these are two resistors in series. We know that for resistors in series, we find the equivalent by adding those guys up, equals 20 ohms. Okay, we could leave it like this, but it's a little messy. Let's redraw once more with the final simplified circuit. So we've got our 50 microfarad equivalent capacitance here, and our 20 ohm equivalent resistance here. Let's make sure we're still thinking about current. So the current I is the same right here, current I is the same right here, current I is the same right here. Because I haven't changed anything going through that 8 ohm. So whatever current is put out here, still the same after we draw the equivalents. So if I can find this current with this equivalent, then I found the answer to the current through the 8 ohm resistor. So let's write down our equation for the current in a discharging capacitor. We know that I is equal to I0 e to the minus t divided by tau. We know that we want the current at some time when it's equal to 1/2 of the initial current, so 0.5 I0. Those I0s cancel. Let's remember that tau is R times C, resistance times capacitance. We'd like to get rid of our E so that we can find our time t. Let's take the natural log of both sides. And let's solve for t. T is equal to minus R times C times the natural log of 0.5 equals minus 20 ohms times 50 microfarads. Remember, micro is times 10 to the minus 6 times the natural log of 0.5. Put that through the calculator, we get 0.000693 seconds, or if you prefer milliseconds, 0.693 milliseconds. So that's how long it takes to get down to half its original current.